Greetings, everybody. So in this problem, what we're asked to do is to find the surface area of a surface generated by rotating the function given by the parametric curve x of t is equal to 2t cubed and y of t is equal to t squared over the interval with t going from 0 to 2, and we want to rotate this around the x-axis. So basically the idea is that anytime that we've got a curve that we're kind of rotating around the x-axis, our curve could be doing something like this. And as we rotate that curve around the x-axis, we're really going to get something that maybe has a shape that looks something like this. So the idea when we're looking kind of for surface area is that we're really kind of taking this and we're dividing it up into infinitesimal little strips that go around this object. And so those infinitesimal little strips are going to have a width on them of ds, or it's going to have a height on them of ds, but then the length will be the actual circumference of our circle, of that circular piece. And when we're rotating around the x-axis, then our radius is actually going to be given by our function y. And so the surface area, when we're rotating around the x-axis, is really going to be our integral of the circumference of our piece, which is going to be 2 times pi times y, so 2 times pi times the radius. And then the height of our infinitesimal little piece is just going to be ds. And so we're going to do this over our entire curve, gamma. So now let's take our functions that were given and plug them into this formula. So for a curve given by x is equal to t cubed, y is equal to t squared, remember that our arc length form is going to be given by the square root of the square of dx dt plus the square of dy dt, and that's times dt. So for our dx dt, for that we will just have 6t squared. For our dy dt, we will have 2t, so that for our ds, we're going to have the square root of 6t squared squared plus 2t squared dt. So when we simplify this out, what we really get then is 36t to the fourth plus 4t squared, and the square root of all of that, dt. Well, if we go ahead and take out a 4t squared from that, so if we have a 4t squared, that's going to give us a 9t squared plus 1 underneath our square root and dt. Now our values for t will be between 0 and 2. And so since our values for t are going to be positive, when we just take the square root of that, we don't need to worry about positives or negatives. We'll just have positive values. So we'll have 2t times the square root of 9t squared plus 1 dt. Now let's take a look at what our interval is going to be, what our integral will look like when we plug in these values. So our surface area will actually be given by the integral over our curve of 2 times pi times y ds. Well, in our case, our t is going to go from 0 up to 2. So we'll have 2 times pi times y, which was going to be t squared. And then our ds, which we said that was going to be a 2t times the square root of 9t squared plus 1 dt. So if we simplify this integral a little bit, we'll have the integral from 0 up to 2. We'll have a 4 pi times t cubed times the square root of 9t squared plus 1 dt. So now if we look at the possible question values that we have, what we then find is that our answer will be the second option of 4 pi times the integral from 0 to 2 of t cubed times the square root of 9t squared plus 1 dt. So I hope you've enjoyed this example, and I will see you guys in the next video.